thank you so much, Joe. That was a really interesting talk. And the one thing that I got out of that was that from now on, I'll be talking to my friends saying, I eat vegan because I'm boycotting cruelty. So, yeah, that's way more powerful. I love it. Thank you. The other thing I'd like to say is that uh, change happens very, very, very slowly, as Jonathan Foley says. He's the head of Drawdown, and then all at once. So that's what's happening here. I fully believe, and there are signs of it happening already, but it makes our role, the influence role, way more important because people are going to have to know what to do when we all change. So we're going to be in hot demand. So okay, here's my presentation, some recent research. This is hot off the press, by the way. The second paper came out last month. Um, and these papers, these two papers, one in October last year and this one, reframe what we think we know about what human activities have caused climate change. So I've got a short presentation, and I'll just bring that up. So I hope you can see that there. Okay, so
We can see it.
great. Thank you. Okay, so I bumped something. So this work focuses on that really, really, really interesting topic of accounting. I mean, people hear the accounting word and they sort of their eyes glaze over, but it appears that dodgy accounting has totally skewed our understanding of what causes global warming that we now experience. So this work corrects that. This is the first paper on consistent accounting, came out in October last year. And what it showed was that the two main sources of carbon dioxide, if you ask anyone in the street what is causing climate change, they'll say carbon dioxide from fossil fuels.
Red, we
Okay,
are
so,
seeing your notes also.
okay, how do I? Perhaps I took the wrong share. Yeah, it's my two desktops that are getting in the way.
I think it was fine.
Yeah, please excuse the notes. Yeah, we'll just have to deal with that. It's the second screen that's showing the full screen. So yeah, sorry about that. Okay, so the way they're counted, the carbon dioxide from fossil fuels and the carbon dioxide from land clearing are counted very differently. How did that happen? I don't know. Okay, so what the paper says is let's measure them the same way. Let's determine that carbon dioxide from fossil fuels and carbon dioxide from deforestation both affect the climate in the same way. In fact, what happens is when we release CO2, most of it right now, 2/3 of it is soaked up by growing vegetation, not just soaked up, sunk. It's not part of a cycle, it's sunk away. So this is what they reasoned. They reasoned that it's just the amount that's in the atmosphere that affects the climate. Therefore, for land clearing, let's just take the amount that's in the atmosphere, and that's the net of the accounting. Whereas for fossil fuels, they said, oh, it's the whole emission we should count, not only what's left in the atmosphere. So that's gross accounting. What my paper does is say we should use consistent accounting, either net or gross. It doesn't matter actually to the calculations, but let's do it the same way. So that's what happens. Land clearing has emitted more carbon dioxide than fossil fuels when measured consistently. Isn't that amazing? Land clearing has emitted more than fossil fuels. So therefore, the industries that use extensive areas of land that used to be forest become the heavy emitters. And this is what the second paper is all about. The second paper uses two more things. It uses a new measure of comparing different gases called effective radiative forcing. Sorry for the long names, but it's the best science we have that tells us what gases have caused what warming. And secondly, we have also, this is dodgy accounting once more. We're advocating inclusive accounting. We include everything, heating and cooling. Up until now, the cooling emissions have been largely ignored. So let's include them. If we're going to do a proper accounting, let's include them. So that's these are the three things that totally change the landscape on our understanding of what human activities are causing climate change. We use consistent carbon accounting. We use effective radiative forcing. This is the best science we have now. And we use inclusive accounting, include the cooling. So those three things, when put together, make a huge difference. The other thing we do is we use data that is the best we've got. We now have time series data of 11 different gases, emissions, going back to 1750. We have yearly emissions data for land, gross and net as well. So we have a full suite of data now. You know, it's being refined, it's getting better, but we have a full suite of emissions data, cooling and heating. And we also have this measure, which is effective radiative forcing, which I've mentioned. And this is published by the IPCC in their last assessment, their sixth assessment, showed the the emissions-based effective radiative forcing of each of the gases, in fact, 11 different gases. So there's carbon dioxide, there's methane, nitrous oxide, halocarbons, nitrogen oxides, etc. And these ones here, this line is the heating cooling line. So there's heating on the right-hand side. On the left is cooling. So all of these coolings emissions, these are the aerosols that are emitted. If you go to a big industrial city, you'll see a grey smog. And that smog is aerosols emitted when we burn fossil fuels. Now that reflects the sun's rays very strongly. And up until now, it's prevented nearly a degree of warming. So this is the latest science and the latest data. So no one can argue this interpretation. It's not my data. It's using other data. It's using ERFs from the IPCC. No one can argue those things. So using effective radiative forcing, had we calculated methane's warming using the metric that we use now, which is a thing called global warming potential, which a lot of people argue about, that's what you hear a lot of arguments about. If we, rather than using that, if we use this effective radiative forcing, we find that methane has produced 3 times more warming than we thought. So methane has actually produced half of the warming we now experience. This is a major, major thing, because what it means is that policy can now look hard-headed at what is causing climate change. So if methane, to me, it's number one, then that is the issue that we really need to be looking at if we need to tackle climate change. And also these cooling emissions, as I said, they've balanced, they've offset, they've stopped nearly a degree of warming. So if we include those in the mix, we find this. Now, this is a graph. This is in the paper, the last paper. We've got heating above the line and cooling below the line. And fossil fuels produce a lot of heating, but they also produce a lot of cooling. Agriculture produces mostly heating, very little cooling. And that blue part there is the albedo. When you cut trees down mostly in the snow, in the high latitudes, that reflects more sunshine. So cutting trees down with snow on the ground or ice, it reflects sunshine. So that's called albedo change. We included that as well. So we've got every little bit of data that we could possibly put into the mix. And you see here that the black dots here represent the net warming. So fossil fuels net warming is there. Agriculture's net warming is way up here. Agriculture caused 60% of global warming. Within that, animal agriculture caused 53%, and fossil fuels caused 18%. So that's animal agriculture there. So animal agriculture is the leading cause of climate change. And the three reasons for this are that deforestation carbon has been underestimated by a factor of 3. That's huge. Methane's heating has been underestimated by a factor of 3. That's huge. And cooling aerosols are just not counted. And that's also huge. Put that together, and I've mentioned data. We've got the latest and the greatest. Put that together, and you find that agriculture has caused 60% of current global warming, and fossil fuels have caused 18% of current global warming. Of course, there's a caveat here in that the cooling aerosols that have prevented further warming, they're being cleaned up. Europe did it decades ago. North America did it decades ago. They cleaned their skies. And now we're cleaning up the dirtiest of all, which is the shipping emissions. And also Asia is concentrating on aerosols. So as we clean up the nasty aerosols, they cause a lot of health and problems, and also they suppress crop growth as well. So as we clean those up, we're going to expose more warming from fossil fuels. So that's the caveat. This is a measure as at 2020. By the end of the century, that unless we draw down that carbon dioxide, which we can, unless we do that, fossil fuels by the end of the century will be the major contributor to global warming by then. But right now, animal agriculture is the greatest cause of the climate change we now experience. Also, I've been questioned on, well, what about current emissions? Shouldn't we also measure agriculture or animal agriculture as a proportion of current emissions? And that's really interesting, because what we did is we did several sensitivity analyses with this data. And what I did was, rather than take the full period from 1720 to 1750 to 2020, I took the last 10 years of emissions data and plugged that into the humongous spreadsheets. And it works out that even using the emissions data for the last 10 years, agriculture is still the greater emission source than fossil fuels. It's about 43% to agriculture, 37% to fossil fuels. So that's not a very exact measurement. It's just a sensitivity analysis, because we still use the effective radiative forcing over the entire period. We should really look at it over that decade, but it gives you a bit of an understanding. So even if you take the most recent emissions data, agriculture is still ahead of fossil fuels. So that sort of answers that question. And the other thing that's exposed, if you like, by this work is that by using net accounting for land clearing, we've effectively hidden the amount of drawdown. And that is a serious error. And that has limited in our understanding the strength of forests. At the moment, there's criticism in certain areas with big wildfires, etc. Some authors are saying, look, there's more emissions of carbon than there is drawdown. Alarm, alarm, alarm. But if you look at the global picture, you find that up until now, the forests mainly, actually, the forests hold 90% of the above ground carbon. So forests are critical. Soils move very slowly. So the forests are the big thing. So up until now, forests mainly have locked up thousands of billions of tons of CO2. They've locked up 2/3 of all emissions, both from fossil fuels and from land clearing. So if you look at it in that sense, nature has upped its act. There's this thing called carbon dioxide fertilization. So what's happened is that the extra carbon dioxide in the atmosphere, nature has stepped up. All the forests, all the vegetation is soaking up more and more and more carbon. So even though we've cut down half the trees on planet Earth, we've destroyed 3 trillion of the 6 trillion trees, even though we've cut down half, the trees that remain hold twice the amount of carbon than the original forests did due to carbon dioxide fertilization. So nature is working overtime. And it's not just a small amount, it's massive. So if you look at the entire period since 1750, nature has the vegetation and the oceans and the soil carbon have mopped up 3/4 of all carbon dioxide emissions. And in the last decade, they've mopped up 2/3. So this machine, this nature is doing its best, but it's falling behind, right? And in fact, it's about 3 decades behind. So if we could just stop everything for 3 decades, nature would slurp it all up, and we'd have no more climate change to worry about. So that's the end of that presentation. So